Welcome to this explainer. Today, we are diving into a massively viral moment you've probably seen, that Cybertruck tow hitch failure. We're going to break this whole thing down using pure physics, regulatory law, and a little material science to figure out exactly what went down and, honestly, what it means for the truck long term.
Here is our roadmap for today. We're going to look at the incident and the law, the real-world physics of towing, industry standards, the battle between steel and cast aluminum, and finally, a big question of longevity.
All right, let's jump straight into Section 1, the incident and the law. Did it actually fail? Okay, so let's talk about that viral static pull test. If you caught the testing done by Zach over at Jerry Rig Everything, you literally watched this cast aluminum hitch snap totally clean off the truck when the scale hit exactly 10,400 pounds of force. Now, at first glance, that number sounds a little alarming, right? Because it's noticeably under the truck's official 11,000-pound tow rating. You'd instinctively think, hey, if it's rated for 11,000 pounds, the hitch itself should easily survive 11,000 pounds of direct pulling force. But here is the really fascinating part. If you look at the Society of Automotive Engineers, specifically their J2807 and J684 regulations, the legal minimum requirement for a truck in this class is actually calculated using a specific formula. It's 0.47 times the nominal capacity plus 480 pounds. So for the Cybertruck, that legal minimum is actually only 5,650 pounds. Since the hitch broke at 10,400 pounds, it absolutely smashes that minimum legal requirement, so strictly from a regulatory standpoint, you can breathe easy. It completely passes. Tesla's lead engineer, Wes Morrow, actually chimed in on this test, and he hit the nail on the head. Standard industry practice dictates that your maximum static tongue weight should be about 10% of your total tow rating. So for an 11,000-pound trailer, your static tongue weight sits at 1,100 pounds. Snapping at 10,400 pounds means you've got a massive, nearly 10x safety factor in a static environment, meaning on paper and legally speaking, the hitch is perfectly sound. Which brings us to Section 2, the physics of towing, static math versus real-world dynamics. See, the thing is, towing doesn't just happen on a stationary whiteboard, right? It happens on dynamic, messy roads where geometry, momentum, and gravity totally change the math. And the absolute key concept here is something called load transfer. Load transfer explains exactly why that standard 10% static tongue weight at 1,100 pounds is absolutely not the maximum force your hitch is going to feel out in the wild. When you're driving, forces are constantly shifting all over the place due to road grades, accelerating, and braking. Let's do a quick real-world physics check to see how these forces just compound. Picture this. You're towing a trailer, and its center of mass is sitting 3 feet back and 3 feet up from the hitch. If you have to slam on the brakes for a hard 1G emergency stop, the physics involved practically shift massive amounts of weight completely forward. To counteract the trailer tipping up, the downward force on that hitch basically becomes the entire weight of the trailer, 11,000 pounds. Now imagine hitting a pothole at that exact same second. Real-world testing shows that road impacts can multiply force by 3G. Suddenly, that 10,400-pound breaking point we saw in the static test, it is very easily exceeded, even if you followed every single rule in the owner's manual. Let's move on to Section 3, industry standards, how legacy automakers test. To really get a grip on this, we should look at how traditional truck manufacturers handle these insane real-world physics. Automakers like Ram actually test with a much harsher 15% tongue weight, not 10%. More importantly, they instrument their test vehicles to measure those exact 3G force spikes we just talked about. And they engineer their components to survive that specific abuse for a target of 120,000 miles of real-world towing. They know these massive load transfers happen out on the road, so they build the margins in to handle them dynamically, not just statically. All right, Section 4, steel versus cast aluminum. Let's look at the metallurgy of a tow hitch. This is where we hit the fundamental core difference between traditional frames and Tesla's casting. It literally all comes down to the metal. Legacy trucks, they use steel frames. Now, steel is about 3 times stiffer than aluminum, meaning it fights against bending under heavy loads. But crucially, it has 5 to 10 times higher toughness. In engineering, toughness is a material's ability to absorb energy without fracturing. Steel is highly ductile, meaning it absorbs energy, it deforms, and it bends a lot under extreme stress long before it actually breaks. Cast aluminum, on the other hand, is stiff, but it's incredibly brittle. When cast aluminum hits its limit, it doesn't bend to warn you, it simply snaps cleanly in half. Which, as you saw, is exactly what happened in that viral test. And this specific material fragility isn't a secret. It's very well known in the engineering world. Actually, it's the exact reason why European Regulation 55 mandates that critical hitch components, the parts where a failure could mean your trailer literally separates from your vehicle, must be made of steel. Now, you can technically use other materials over there, but you have to legally prove an equivalence of performance. And that is incredibly difficult to do with aluminum because of how it handles stress.
But the absolute #1 most critical concept for understanding long-term towing safety is a little thing called a materials endurance limit. In material science, we look at what's called an SN fatigue curve. This basically plots stress against the number of cycles a material can handle before failing from fatigue.
When you look at long-term durability, the contrast is kind of mind-blowing. Steel has an endurance limit. That means as long as the stress you put on it stays below a certain threshold, the steel will never fatigue. It can literally last forever, cycling infinitely. But aluminum? Aluminum has absolutely no endurance limit, none whatsoever. That means every single time you apply stress to it, every pothole, every hard break, every single bump on the highway, it permanently weakens the metal. Which naturally leads us to Section 5, a question of longevity. The irony of the design. This lack of an endurance limit raises a massive question about choosing an aluminum casting for heavy-duty repetitive work. Because aluminum degrades with every single stress cycle, we kind of have to look at that initial test in a whole new light. That 10,400-pound braking limit we saw on day 1, that is not a permanent number. It will inevitably decrease as the truck ages and the metal gets tired. A heavy load that a brand new hitch could easily survive might just snap a hitch that has, say, 50,000 miles of towing wear and tear on it.
From an engineering perspective, there's actually a pretty striking irony here. The Cybertruck is wrapped in this incredibly tough, highly resistant, practically bulletproof stainless steel on the outside. But for its core structural towing component, the exact place where you desperately need toughness and flexibility, it relies on a brittle, fatigue-prone cast aluminum.
And this structural contradiction really stands in stark contrast to the original vision for the vehicle. As Elon Musk explicitly stated during the Cybertruck's unveiling, the goal was to build a truck that avoided being fake tough. But placing a brittle casting at the absolute highest stress point of a towing vehicle definitely challenges that philosophy when you stack it up against traditional steel frames. So, bringing it all together, yes, the hitch legally passes the SAE static tests today, and you're 100% within regulations driving it right off the lot. But the ultimate question we are left with as these trucks rack up miles is this. Considering the complete lack of an endurance limit and the absolute inevitability of metal fatigue, for exactly how many miles of real-world, max-capacity towing is this casting truly designed to survive? I guess only time, and maybe a few more heavily loaded trailers will tell.